employ a chemistry teacher, you don't pay the person as much as someone working in oil and gas. But day and night, the chemistry teacher is in the lab. One day will come, he or she will discover something that can become a patent. And so scientists may not be too extravagant in their lifestyle, but they are producing solutions that can feed even the entire society. But here in Nigeria, like in other underdeveloped countries or developing countries, scientists don't have the equipment that they need. Physics laboratories don't have as much equipment that they need to practice. How would the teacher or the lab technician be inspired to come up with new theories?
Please, I'm going to invite somebody that needs no introduction. So the one and only Dr. Ayoola, the CEO and father of Great Robotics Nigeria, the best robotics in Nigeria. So let's give it to him. Thank you, sir.
Some time ago, in the 13th century, the firearm was discovered or developed. And then in the 14th century, it developed into handguns and then rifles later on in the 19th century. But then that was not enough to make some scientists feel we are where we want to be. They kept looking into it. How can we get something even better? Of course, with a gun, if you are a hunter, that's all. Go into the forest, fire maybe a jackal or a hyena or anything, and then you have something for home. But then they discovered that no, we need to reinvent this technology. What did they do? They went back to the lab to rediscover the atomic theory. There was a need to properly and better understand the structure of the atom. What I'm trying to say is that scientists are always curious, must always remain curious and hungry for knowledge. And it doesn't mean, okay, let's build on what we are seeing. No. Sometimes we need to go back to the foundation, the atomic laws, the theories. Is it true that an atom is made of protons, neutrons, and electrons? Are there some other characteristics or properties that if we know, we can further advance society? And then they discovered some discrepancies in the research, and later on developed what we now have as the atomic bombs, which, whether you like it or not, whether it's for good or for bad, is a significant development in the history of technology, where a very simple gunpowder that normally would have been used to just fire a shot can now lead to severe amounts of explosion, or let me say energy, atomic energy. Could be used for power generation, could be used for havoc, could be used for blasting rocks as well. Now, that's on one side. So also in the area of energy for all, we talk about power generation from hydroelectric power dams and the likes. And people are thinking, wait, can't we get energy in a more, I won't say safer now, but in a more controlled environment? And then they brought about the issue of nuclear energy. In the area of computation, we talk about AI today because computers are faster. What some mobile phones can do, back in the days, a big mainframe computer could not even do. And even with what we are seeing today, scientists are still not satisfied. Right now, the latest research in the area of computing is the development of quantum computers, which is an aspect of quantum physics. It's about how can we get a processor to process 10,000 times faster than what it is doing now. That means the things that your laptop cannot do, in the next 5 to 10 years' time, mobile phones will be doing them even better. I want to send you a video and it's taking time. I want to download something from the internet and it's taking time. It will be a lot faster. People don't just wake up and bring about new technologies. They go to the labs. So here's the question. When you have a high school, let's not even talk about university now. a high school that teaches physics, chemistry, mathematics, and biology, and you have teachers who are there. One reason teachers don't get paid so much is because they are still learning like students. They are in an environment where they can easily learn. And who knows what they will discover might feed the rest of their family for ages. So the idea is that you employ a chemistry teacher, you don't pay the person as much as someone working in oil and gas. But day and night, the chemistry teacher is in the lab. One day will come, he or she will discover something that can become a patent. And so scientists may not be too extravagant in their lifestyle, but they are producing solutions that can feed even the entire society. But here in Nigeria, like in other underdeveloped countries or developing countries, scientists don't have the equipment that they need. Physics laboratories don't have as much equipment that they need to practice. How would the teacher or the lab technician be inspired to come up with new theories? So, if we think about this and think over and over again, it boils down to one simple thing. Our country is not financially capable of buying the kind of equipment that the labs need. That's what the government will say. We are working on it. We have other problems. We need donors to do this for us. And it is very true that the cost of some of this laboratory equipment is super high. I was doing my PhD in the UK, and at a point I went on to do postdoc. And there was one particular device that was handed over to me by someone who had finished earlier. And I asked him, sorry, this thing you are giving me, what is it for? He said, he doesn't know. Somebody else handed it over to him, so he handed it over to me. I said, okay, that means it's even useless. So I put it in a box, in a carton. Then while I was doing my research, I was trying to build an underwater communication system. And to do that, you must transmit a signal underwater, receive the signal, and study the difference, whether it has been attenuated, whether it has been affected or not. And also so many other things. And then I realized I needed an equipment. And when I went online, that equipment I found was 25,000 pounds. In Nigeria, that's 50 million naira. And it was funny that was the same equipment I had abandoned in one carton in the lab. So I quickly brought it out and used the equipment. And I was thinking that, wow, if this simple equipment can be this expensive, you can be sure some labs in Nigeria won't have it. And it was helpful because I was trying to build a technology that does not exist yet. It's still constantly under research. Underwater communication, wireless communication, underwater. But if you don't have that equipment, how would you break through? Countries invest heavily in medical or, let me say, laboratory equipment. Our own country can hardly afford it. So yes, money is a problem. But when I looked at what that device was doing, because I already had my PhD and all, so I already understood most of the technology inside it, I discovered that maybe with 2 million naira put together, I can actually make the same device. So while I was coming home to Nigeria in 2019, I bought some of the components I would need. I bought an STM32 microcontroller board, and of course the rest is just to have some power around it and some 3D printed housing for it. The kind of BNC connectors and all that I need to be outside the box, and that was all. But you can't do that if you don't have the people that will be working with you. So I decided to start a training facility that will train people to become techies, not just for software now, but for hardware. And that is where our government is not getting it right. We always think the problem is getting the funds to equip the labs, whereas the solution is equipping the brain or the minds of the people who are going to later bring up the solutions you need. I was going through one of my old computers and I saw a picture a screenshot of one of my WhatsApp status that I posted some years ago, and I wrote it there that you are not an engineer yet until you can walk into an empty room and come out with a solution, with a device, with a gadget. And that means that we don't need to spend billions. And that's why I laugh when I see the government commissioning facilities with billions. And then you hear, oh, they have spent 10 billion naira to build this facility. Will it be able to, who will maintain it? You are donating heavy facilities that even the people you are employing don't know about. Once they spoil it like this, once they try to use it, if they try to use it, and it spoils, what will happen? They'll just, don't touch it. We have not started using it, please. Don't touch it yet. 10 years down the line, you might realize that thing is not working. I was in a meeting 3 days ago in UI where we were deliberating on government policies that can enable medical equipment that are moribund in the hospitals to be remanufactured, repaired, and revitalized. Because there are so many of such equipment that we cannot handle. And it's so sad that in this room, I don't want to do any kind of census, but if I ask how many people study electrical electronics or mechanical and so on, people might raise up their hands. And if I say, okay, if you see an X-ray machine that is bad, you know how to fix it? We probably don't know. Either because the labs were not equipped enough to even expose you to these things, or because you just didn't have enough practical, even in the other basic areas. So we need to invest in the minds of those that will solve our problems. Importing heavy equipment is not the solution. It's not sustainable. When you go for bilateral trade discussions, when I went to the US in April this year, the idea was, okay, let's see what the people in the US have that you need. Let's see what you have that they need. So you can encourage each other to do some kind of bilateral trade or transactions. And my own was, we want some sort of training. We want to know about this chip technology, microchip technology, which is still a reserve of the US. We want to know about it. But then what you get is, no, whatever you need, just tell us, we will do it and send to you. We don't want to be a consumer nation. We don't need you to send us the perfect, don't donate to us equipment that are working for the labs. Train our people. Although there's a big problem too. When they train our people, will they come back? Even those we are training here are leaving. So we need to, there's definitely another discussion for another day. But the point I'm trying to make is that when we train those that will solve our problems, we will now discover something. That most of those things we need to build, whether it's an X-ray machine or a 3D printer, that we know we will need, we'll be able to locally make them here. It's only when you understand the way these things work, you can come up with, oh, and I even have something in my village that can be used to make this. So let's talk about the skills that we need to train ourselves in to be able to build the solutions we need. Because something I have at the back of my mind, which I published online in 2018, is what I call national education. And that's an educational policy that makes sure that we're not just training people at polytechnic level, university level. There is a role for everyone. I want a case where those who are in polytechnics will be making technological solutions that the laboratories in secondary schools will use. Those in secondary schools should be building lab solutions, lab technologies that those in primary school would use. So that way, we are sure that it's an impactful education, knowledge transfer. If your school cannot boast of producing any, whether it's an ammeter, or you know how when we're in primary school, I don't know if you did it, but we made torchlight. Do you make torchlight? We put batteries together with one bulb, and it worked. At a point, we even made detergents. We kind of grounded eggshells and some things. It needs to be sustained. Let the people in the schools know that education is not complete unless you can solve someone's problem. Then those in the universities, don't just do final year project for the sake of it, or any laboratory experiments. It must be based on what those in the polytechnics need. Because at the polytechnic level, they apply. They don't just learn theory, they apply it. So that way, we will know that we are solving our problems. So now the skills I think we need, under the banner of emerging technologies, number one, it is 3D printing. I say 3D printing. Now, not that for industrial mass production level kind of manufacturing, 3D is what we're going to use, no. But 3D is used for prototyping. With 3D, you can come up with any idea of whatever, and then get this to do additive manufacturing. I'm sure, has somebody talked about this? Okay. By adding filament, it will build what you had created in your mind. And there is some kind of joy you get when the thing you had in your mind and you drew on the computer comes out exactly right. But then how do you get that to an actual object, to an actual commercial thing? We can use that to actually explain better to those who don't know anything about 3D designs, the blacksmiths. When you take it to them and say, this is what I want you to build, but make it bigger. They can say, oh, okay, they now know, they can see it. But beyond that, we can use this to also make molds that when we pour some chemicals into it and it hardens, it takes the shape that we have designed. So you know, there is what they call resin and additive and hardener. So when you put them together and you leave it for a while, when you stir it, it becomes really hard, and then that is the housing compartment you're trying to build. Later, when you have money, you can do plastic molding and all. But that's the first step, to allow people express their creativity. And that means you don't even have to be a tech person. You can just be someone that wants to modify the way this microphone looks. Maybe you have an idea of how better one can grip it. We have cases where people don't put the microphone close to their mouth. Is there anything you can do in the design? Draw it with hand sketch first. Then later on, transform it into a 3D design, if you can learn any of those platforms. And then whatever you have designed online, on your computer, it takes nothing to build. Where will you find this? I believe this one belongs to ATech. Some secondary schools have as well. In UI, that's what they call the UI design studio. You just need to walk into the place and tell them, somebody will pick it up from you and then design and build it. Because these are funded laboratories. There's also one in UI, donated by the French embassy. And some people do it as businesses. If you go online and look for, you will pay them per gram. You can build it. Once you can do this, that's one step in terms of problem solving. I attended a program and they gave us key holder as souvenir. The key holder was made by 3D printing. So you can print a logo or anything. The second skill is Internet of Things. Internet of Things is the next big thing now. Because when we talk of AI and we talk of robotics, these are all possible when things are smart. Things are smart when those things can access the internet. That's why your phones are smart. But I want this chair to be smart. I want this, what's the name of this thing again? Lantern to be smart. In fact, I want the microphone to be smart so that I don't need to be streaming through a computer again. Once I'm speaking on this mic, there should be an address that you will go to and you will listen to the audio stream. What that means is, what components, what electronic board can I place inside this that will be able to convert my audio signals to, of course, to electronic signals and then transmit it via the internet. And if you ask anybody that has learned embedded systems and IoT, they already know what to put. There are sensors for sounds. Convert that using analog signals, analog inputs, into waves, and you transmit the wave. Wherever it goes to, is stored on the computer as a dot wave. Now, that is IoT for a microphone. Imagine reinventing that. You don't have to even build it. Just patent that technology. And those who have the capacity to build would pay you royalties for it. And this is something that once you do it in Nigeria, the whole world wants it. A microphone that has its own ID. You can just snap the QR code and put it online. Anybody can listen to whatever you're saying. Pastors will buy it for sure. Internet of Things is beyond this. It's about getting data. For instance, and when I say getting data, it could be for personal use, it could be for commercial use. So getting data just means knowing what is going on somewhere and recording it online without you being there. So it's beyond what we can conceptualize just in one, here, right now. IoT is big. The next thing after IoT is cybersecurity. The world has come to a point where everybody wants their gadgets to be smart, but they are afraid of who will have access to that information. You tell someone, and I think this is very common, you tell someone, you know what, your house, we're going to put cameras everywhere so that wherever you are, you can see what's going on in your house. And then you're thinking, so that you can be watching me, right? Some people right now, they don't allow their webcams on their laptop to be open. They put some tape on it because they don't believe that it's only them. They believe that somebody might be watching it. And while we can laugh, it's actually very possible when you know the technology. I can give you an app that maybe just helps you calculate, a calculator app on your phone. And that app on your phone, even though when you open it, it looks like a calculator, may be doing different things. It could be checking your location, could be checking the calls you're receiving, it could be just listening to your microphone or anything. Fine, it will ask for permissions, and then you will accept because you not think about it. Many times we read agreements, we never read user agreement, we just agree. Because if you don't agree, you can't use the app. So the question is, how safe are we? I was in a conversation that was going on regarding cybersecurity, and this was at the headquarters of Citibank in New York, and the question was, what are they doing to protect data? And they said, see, they have the best technology for encrypting the data in their database, which means that if you hack into their database, you might not be able to get anything from it. It's just be gibberish to you. But that's not what they're worried about. They're worried about the safety of the passwords that those who have access to that data, the safety of their passwords. Because there may be a database of everybody's, let me say, medical record now. And I'm the only one with the password. So if you hack into the record, it will be gibberish. What does my password do? My password means that once the computer sees this password, all the encrypted information or data will be decrypted so I can read it. That's why I have access to it. So what it now means is that a hacker does not have to try to hack the database. They will just try to steal my password. And once they steal my password, they have access to it. So every company, every serious organization in the world is thinking about this issue of cybersecurity. Because they've tried their best to help all of us to have complicated passwords. But we are also complaining. Just because you entered your password wrongly 3 times, next thing they will say is you are blocked. Now you have to check your email. Now you have to check another phone you've used before. So stressful. They will even tell you 2FA, two-factor authentication. Some will tell you, don't use just letters. You have to put capital, you have to put characters, you have to even... Then an association, I can't remember how they call them now, ANSI or something like that, they met about 3 months ago in the US and they said they have come up with another way of securing the passwords. Now, they're not going to force anybody. The new standard is you won't be forced to have multiple characters, but you must have a sentence that is at least 64 characters. So now, maybe in the next 3 months, when you want to open any account, your new password has to be a sentence. The reason is that, just like with cryptocurrencies, the longer the characters, the more time it will take for anybody to guess it, or for any computer to guess it. Now, the real problem is that with quantum computing coming up soon, computers will be 10,000 times faster. So what you think would take them 10 days to crack, in 1 second, they will crack it, something like that. But then, when it comes to cybersecurity, we have ways to deal with this problem. But people just need to think about it, and that could be you thinking about it. Like for me, I have come up with a solution to passwords that will be more secured. And that is by changing passwords from strings to formulas. A formula y equals 3x plus 5 means that when x is 1, y will be 8. When x is 2, y will be what? 10. 11. I'm sure you'll be like, it doesn't know maths. I didn't write it down now. But the point is this. If x depends on the day of the week, then that means on Monday, Y would be, if Monday is the first day of the, let's say Sunday is the first day of the week. On Monday, Y will be 8. On Tuesday, Y will be 11. Now, 8 or 11 will be my password. So when you see me typing password 8 today, you might think that's my password. But no, it's just a formula. Tomorrow, it will be password 11. So if you are trying to guess my password, as long as you did not guess it at the right time, it would have changed. So that is something we are coming up with at RAIN. But now, beyond that, there are so many other areas of cybersecurity that the world needs from all of us, because data is the new oil. Now, beyond cybersecurity and IoT and 3D printing, here comes the big one, AI. And AI is something that you could get into that space and solve real problems just by learning either of two things I'm going to mention now. You could either be an AI developer or an AI engineer. So if you are an AI developer, you are helping to develop solutions using AI. And there are so many organizations and companies that need AI. So what is AI? AI is basically allowing computers to reason like humans, analyze, think, and decide. How do we program what humans do into a computer? It's just two things, statistics and mathematics. All the things we do is based on logic, and it's all in statistics. For example, if I tell you, okay, it takes 3 men 2 days to finish a job, how many days will it take 6 men to finish that job? You just, in your mind, you calculate something. If I tell you, I ate rice in the morning, beans in the afternoon, what will I eat in the evening? If you have access to my history, how I eat, you can quickly answer that question. If I tell you I was going to the market to buy plantain and maybe potato, I went to the market, there was no potato, but everything else was in the market. What did I buy? It makes common sense. You would have bought the plantain now, since there was no potato, but you didn't say there was no plantain. So common sense that we human beings use day to day, statistically, it can be developed such that you don't need a human mind to make the inferences that we make. And that is what AI is about. It goes from analyzing data in our businesses, data in our, if it's about the genes now, our genomics, in healthcare and so on. So when it comes to applying AI to solve real problems, there are so many things that can be done. In the area of drug discovery as well. So if you are an expert in developing solutions, just using existing AI theories, then you are an AI developer. And it's getting to a point now where all businesses would only be able to compete if they are utilizing AI. I'll give you an example. So there is a company that we help to automate, their interactions with customers. And this company used to have like 20 members of staff who are just chatting with customers. It's a forex kind of company where they buy and sell currencies. And they need to always be chatting. How much currency? How much do you want? Okay, what's your account detail? And so on. However, there were errors because when new staff joined them, they need to tell themselves, no, this is not how we do it. This is what you say. This is what you do. This is how you do it. You push the data to this place. So there was a long lag between when someone joins and when the person becomes a pro. So they came to us and said, can you automate this? And it's under workflow automation. Workflow automation means that everything we usually do, can you automate it into a software so that nobody needs to think. They'll be prompted on what to do at the right time. It's also called robot process automation. Banks use it. Banks use it a lot. Now, we built, using Python programming, an application that can converse with customers in ways that the customer would think it's a human being, but with the nuance of the job that normal human beings used to learn. So now, they're able to attend to let me not say 10,000, they're able to attend to hundreds of customers at the same time. Whereas with 20 workers attending to hundreds of customers, that's usually a queue. So with AI and of course workflow automation, we have solved that problem for them. So if you were competing with them in the market, their process would seem so efficient. Customers will be moved to use them because they are faster and they know what they're doing. So it's getting to a point where every business would now want to apply AI in one or two of their processes, and they'll be looking for AI developers. The second aspect is the AI engineer, those who can actually remodel some of the packages we use in AI. As far as that one is concerned, you need to study it in the university, because there's a lot of mathematical theories you will be re-engineering. So when we say regression, to see the relationship between data, X and Y, in the world of AI, we are dealing with matrices. And matrices not of numbers, but of pictures. You know, every picture is a matrix. And the higher the resolution, the larger the matrix. So when you now start talking about regression analysis and so many other mathematical theories, it gets a lot complicated. But it is those packages that they build that the AI developer would use to say, oh yes, we can easily do this. And a normal AI developer will tell you, okay, if you want to do computer vision, you will need YOLO, you will need OpenCV. Who builds the YOLO? Who builds the OpenCV? The AI engineer. So these are areas. The last one I will talk about is robotics. Today, almost every area of our lives needs robots, because human beings are getting lazier by the day. Nobody wants to do anything again. We want to enjoy life. And there is nothing wrong with that, honestly speaking. We are supposed to dominate the world and take control. We don't have to be the ones doing everything. Somebody wants to buy petrol at the filling station and you need a human being to attend to you. Why do I even need to get out of my car? Can't my car and the nozzle communicate? I would expect the nozzle to just by itself open, or maybe my car should open the tank itself and the nozzle just gets in and fills the tank. They should even credit each other. I don't need to know about that. Now, when you think about it, the question will be, okay, if that's my project, where do I start from? That's where the knowledge of robotics comes in. Robotics lets you understand that mechanical engineering, electrical engineering, and computer engineering have a meeting point. Mechanical engineering is all about, can this thing even move if it wants to do it? For example, let's assume this is a nozzle of a fuel dispenser, and this is the car. If this nozzle were smart enough to know that this is the tank of the car, can it get to it? If the answer is yes, okay, let's build a mechanical system that can actually manually do that, that can mechanically do that. You think about joints, think about mobility, you think about the wheels, the aesthetics as well. You design, you develop, you test it. Once that's possible, the next question will be, okay, who is going to make this bend to where it needs to go to? That's the job of the electronic engineer. And these are the things that make up robotics. Who will decide what kind of motor in place will be able to drive that amount of torque? Torque is something we learn in physics. To bend or to move any particular joint. Now, the mechanical engineer has done his bit. Electrical engineer has also powered the motors that will bend it. How will this whole system know when to bend towards the nozzle and when to actually leave the nozzle? That's where computer engineering comes in. We need a brain on this device, microcontroller. So when you see children learning Arduino boards, that is a big deal, because Arduino board is the brain of any hardware that must be a robot. With Arduino, you are basically programming a lower level of a computer. You write codes in C++. In fact, it's pseudo C++ now. It's getting easier for us. And with the codes you've written, the computer would command all of the actuators, that's the motors, to do the right thing at the right time. Now, when you think about robotics, and you think about the problems in our laboratories, it means that if somebody wants to build a 3D printer and donate it to a community school, rather than buy, you can actually automate all of that movement. Mechanical people have to first of all ask themselves, can we build a machine where the hotbed can move back and forth? If the blacksmith in your community can do it, then we're on our way. can we build, of course there's a belt here, but can we build a railing where I don't want to push it now before you will say, you have spoiled it. But you know what I'm trying to say. I'm supposed to push it away so that you can see that it's on a railing whereby it can move forward and backwards. Once the mechanical person or the blacksmith in the community can assure you that he or she can do that, the next thing is, what should we put that will make this particular portion slide? A motor. There are stepper motors around this, within this particular compartments, about 3 stepper motors. If I'm not mistaken, it should be 3. Then the computer engineer, or whoever can program, now we call them embedded systems engineers because they put computers inside machines, will program it so that based on the design you have drawn on computer, it will move the extruder accordingly. So that means that apart from making it look so beautiful, where we can say we're not there yet in terms of manufacturing, the functionality of this can actually be developed and handed over to a community school. Imagine that is a task given to people in the polytechnics. You have the mechanical engineering department, electrical, and you have the computer engineering department. Let them build it as if they are trained, because there's something theory and practical. Now, we can actually use robotics to build solutions. It is the solutions we build for schools that will help inspire the researchers to do more and in fact build further on the technology we are using. And that way we can own the technology we need to solve our problems. Otherwise, in Africa, we will continue to go cap in hand abroad looking for help from countries that have invested in their education. Knowledge transfer is key. If we have only 10 people in Nigeria that have that knowledge, we have to invest in them. But unfortunately, the way the entire world is scaled or skewed, the best brains leave the country. If anybody says he can build a 3D printer or a drone, what do you think the government, the people will start saying? Take him abroad, because we feel that he will be more appreciated there. But if we all leave this country, then who is going to develop our home? And no matter what, we have no place like home. I was in the UK for 7 years doing my master's, PhD, and postdoc, and I said to myself, I am coming back to Nigeria. People said, think about it. Your village people have, they are your matter. I said, I don't care. Because I cannot be in a country where everything is perfect and let my people be in a country where they're struggling and striving. If we have learned one or two things, we must come back. So to every Nigerian out there who are abroad, let's always come back to give back. Nobody is saying don't go back for holiday. Look at me. When I came back in 2019 to Nigeria, I started RAIN. I even applied to lecture at the University of Ibadan, and I was taken. So I was a lecturer for 5 years before I resigned, because I needed to focus a lot more on RAIN. But the point is that even though I came back to Nigeria, I knew that with the knowledge I brought home, opportunities abroad for me will always be there. Today, I've been to the US on a 3-week program sponsored by the US consulate. They called it the leadership program. I've been on conferences at the UAE in Dubai and later another one in Abu Dhabi. I never spend my money to go to these countries because home is where the heart is. And so I always tell young people when they come to RAIN for excursion that, you see, in this room there is a light bulb, but outside there is a sunlight. Which one is brighter? The sunlight or the light bulb? Sunlight. The sunlight. Did the sun leave where it was to come here to shine? You can be like the sun. Anywhere you are, your light will go across the world. So on that note, I want to encourage all of us to upskill. You don't have to stay in there. You can go and come back. 2 weeks, 2 weeks, And then let us apply emerging technology to improve our education in this country. Thank you very much.